As you see the vector over there, the vector was 100 Newton and 35 degrees angle. You notice those two characteristics. First, that they have a number as a value that is 100 in that case. And number two, that they have an angle. In this case, the angle is 35. So vectors have two characteristics, magnitude and direction. To calculate the magnitude, we're going to be using the formula resultant equals the square root of x squared plus y squared. And to get the angle, we're going to be using the formula arctangent of y divided by x. And then I gave you the example, and I told you this method is called components method for adding vectors. And I gave you this example. How many vectors do you see over there? You can write it in the chat. I can barely listen because of the air conditioner. Very good, there are three, okay? So there are three vectors, A, B, and C. So the first thing that we need to do is we need to build a table. And that table is going to contain three columns. The first is vector, the second one is the x component, and the third one is the y component. Remember that the x component is the horizontal component. And the y component is the vertical component. So when we have the horizontal axis, we see an axis like the one I showed you over there, where the right side is positive and the negative side is the left. And in the case of the vertical, we have a vertical axis. Upward is the positive direction, and downward is the negative direction. So the first thing that you need to do is you need to build a table. And we're going to be very organized with this procedure. So I want that you pay attention because we have three vectors. I'm going to put this here next to the table so we can see all the procedure. Okay. Because we have the three vectors, we're going to locate those vectors here in the table. Here, the first one is going to be my vector A. The second one is going to be my vector C. The third one is going to be my vector C. As you can see, I have more rows. But in this case, I'm not going to use the remaining rows because I only have three vectors. If I had more vectors, I will be using the other two rows. Friday, I will solve one more example with more vectors so you can see the whole process. Okay. So what I do in the first place, I'm going to sketch the vector A over here. Wait. Okay. So first things first, in the first, I have esta cosa. So this is what we have in the first vector. Okay, vector A that has an angle of 60 degrees. And the first thing that I need to do is I will analyze the type of angle of this vector. Take a look to the vector A. Okay, guys, wait. Wait a moment, please. Is that this internet is a little bit slow? I'm going to join from another Wi-Fi. Okay. So I want that you focus in this part. I need that you guys focus in this part, in the vector A specifically, okay? I wanted you guys analyze the angle of 60 degrees that I'm giving you here. That angle is touching what axis, the vertical or the horizontal axis?
Horizontal.
Horizontal. So when this occurs, we say that the angle is a horizontal angle. Remember that I gave you the classification of the angles according to the axis that the angle is touching. This angle is touching the horizontal axis, so it is a horizontal angle. So we go back to the vector and we say that this angle is horizontal. Okay, and because it is horizontal, for x, we're gonna be using cosine, and for y, we're gonna be using sine. Now, I'm gonna take my vector and I will draw my components. This vector, where is it going? Right or left? Where is this vector going? Right or left?
Left.
Left. So I get my x component, and because it's going left, I know that it's gonna be negative. Vertically, this vector is going up or down? Vertically, the vector A is going up or down?
Up.
Guys, up or down? Vertically, up or down?
Up.
So you have your vertical component over there, and because it's going up, you know it's going to be positive, okay? So this is important because now that you get the x and y component, you're going to be using these formulas, and you're going to be using the signs that you show already. X component, I'm going to be using cosine, okay? So I say ax is equal to a cosine of the angle. The vector A is the value that is 100 Newton. It's the value of the vector, okay? It's this one over here. It's this one over here. That is the value of the vector A, 100 Newton. So we say AX is equal to 100 Newton cosine of the angle that is 60 degrees. And because we already said that this vector is going left and is negative, we know this answer is going to be negative because it goes to the left. How much is this? You can write it in the chat. your calculator, you will press 100 cos 60 equal. That is 50 Newton. Did you get it now, Kenzie? Don't forget that this is a calculator key. Okay, to calculate the y component is the same formula, but using sine. And it is 100 Newton, sine of 60. How much is this? We know it's positive because it's going up. You can write it in the chat. I got 86.6. Did you get the same answer as me? Oh, yes. Very good. So with this, we finished the first vector. Now we work with the second vector, the vector B. B is 80 Newton. So first I'm going to put it here in the table. My vector B has an angle of 30 degrees and it measures 80 Newton. What type of angle I have in B? Horizontal or vertical? What is the axis that it is touching? Horizontal or the vertical axis?
Horizontal.
It is horizontal, okay? So we say that the angle is horizontal. Therefore, for X, we're gonna be using cosine, and for Y, we're gonna be using sine. And that is important because in the formula, you will use cosine and sine respectively, okay? Now I will complete the triangle. Horizontally, the vector is going right or left? Right or left?
Right.
It is going right. Because it's going to the right, it's going to be positive in X. Vertically, is it going up or down? Vertically, does it go up or down?
Up.
It's going up, okay? So, the arrow is going up. So you know your y is going to be positive. So we calculate the components, okay? Bx equals to b cosine of the angle, and by is b sine of the angle. Bx is equal to 80 Newton, cosine of 30 degrees, Bx is equal to what? I got
69.2.
69.28. Did you get the same answer as me? Did you get the same answer as me?
Yes.
Okay. We do the same procedure for B, and we say that B is equal to 80 Newton, sine of 30 degrees. Because it's going up, we know it's positive. How much is this? $40, very good. 40 newtons. And with this, we finish, very good. With this, we finish the second vector. Now we need to work with the third vector, that is the vector C. Vector C is coming downward. And as you can see, it has a value of 60 Newton. Now, this is the easiest of the three vectors. Among the three, C is the easiest of them. Why? Because you need to analyze. How is this vector moving horizontally? Right or left? Or is not moving horizontally? So how is it? Is it going right, or is it going left, or is it not moving horizontally?
It's not moving horizontally.
Exactly, it's not moving horizontally. So when this happens, when it's not, because it's not moving horizontally, just vertically, in the horizontal component, we're going to write 0 directly, okay? So we can say that Cx is 0 Newton because it's not moving horizontally, it's just going downward, nothing else. Now, what happens vertically? Where is the vector going vertically? Down or up?
Down.
The arrow is going down, so I know that it's going to be negative. And what we do is we just write the same value of the vector, the same 60 that we had initially. We don't need to calculate anything. We just write the symbol to indicate the direction at which it is going. So in the vector C is 0 because it doesn't have a vertical component because it's not moving horizontally. And is negative 60 because it is moving entirely downward, okay? So the full vector, the entire 60 Newton are going straight downward. That's why we just placed the negative symbol over there. And as I told you already, because we don't have more vectors, I'm not gonna be using these other boxes, okay? What comes after? The next step is addition, okay? This symbol represents addition. This symbol is a Greek letter that is called called sigma, and it represents an addition, okay? So we're going to add vertically. We're going to add minus 50 plus 69.28 plus 0. How much is this? This is going to give you all your x components. I got 19.28. Did you get the same answer as me?
Yes, miss.
Okay. Now I will do the same in the other column. I will add 86.6 plus 40 minus 60. How much is this? 66.6. Very good. So what do we do after? We're going to apply these formulas, okay? To calculate the resultant. You're going to replace x with x and y with y. Okay? And we're going to follow the formula. So x, that is 19.28 Newton raised to the second power plus 16.6 Newton raised to the second power. To do this process, in your calculator, you're gonna do this. In your calculator, see the green part, okay? The green part is the calculator. In your calculator, you're gonna do this. 19.28, you're going to press the key x to the second plus 16.6, and you will press the key x to the second. Then you will press equal, then you will press the key for the square root, and then you will press the key of your answer, and then equal. How much you got here?
$69.833.
69.33. Very good. Okay. Now, one instruction that I will give you, and please follow this. Okay, follow this idea. When you calculate the resultant R, please, in the formula, use only positive numbers. So in this formula, you're gonna be using only positive numbers, okay? Only positive values. Only positive values. Even if here the answer gives you, for example, minus 19.28, in the formula, please put it positive. In your calculator, please put it positive. But only in the resultant. When we get the angle, here you have to use the signs that are given. In this case, it's not necessary because the two values are positive, but sometimes you're gonna have a negative answer. When you have that negative answer in this one, in the angle, yes, you're gonna need to use the negative sign. Now, in the case of the angle, we apply the formula arctangent of y divided by x. Y is 66.6 Newton and x is 28 Newton. Here, the newtons and newtons are gonna be canceling each other out, sorry. And then you will get your answer. To do this procedure, follow the green part. You're gonna press the key shift from your calculator, shift, and then you will press the key tan. And then you will open parentheses, and then you will divide 66.6 divided by 19.28, close parentheses, and then press equal. How much is this? $73.85. Very good. 73.85 degrees. Now, I want to show you what these numbers mean. Remember, shift, tangent. Open parenthesis, 66.6 divided by 19.28, close parenthesis, equal 73.85. Now, I want that you guys see what this means, okay? In your quiz, it's not necessary that you do this step. Until here, I will check in the quiz. Now, I want that you see what every number means. X is the horizontal component, and it's almost 20 units. Take a look in the sketch that I show you. X is the horizontal component, and it's almost 20 units, okay? Y is my green component. It measures 66.6, and in the picture, Y is this one, vertical component, okay? If I take a protractor and I measure the angle from the horizontal to my resultant, I will see that this angle is gonna be approximately 74 degrees. So if you take a protractor, you're gonna notice that that angle matches the answer that we got. And 74 degrees is almost the 73.85 that you see over there. So what I want to show you is that every single number that we obtain here in the procedure is represented in the figure. And what is R? The resultant R is 69.33, and it comes from the center to the end of the triangle. And as you know already, the resultant is the hypotenuse of the right triangle that is formed. So what I want to show you is everything from here is a right triangle. And there you have all the information to sketch the right triangle. You have your X, you have your Y, you have the angle, and of course you have the value of the resultant. All of them combined is gonna give you a right triangle like the one that you see over there. On Friday, I will explain another example. And I will send you the PDF file with this. I will upload a video in YouTube so you can rewatch this class if you need it. I'm going to end the meeting now because my students are about to get in, okay?